Hi, everyone. My name is Kofo Okesola. I am a senior software engineer at TIG. I've been working on a project that I call the Canvas for API for the past 2 years, and most of it has taken advantage of AI-assisted development, AI-assisted building, AI-assisted workflows. So I do think I have a bit of experience to share on this topic. A bit more of my background. Before TIG, I worked at companies like Envision that also was a multi-system, multi-service application, application, probably one of the largest systems I've worked on. I have worked at Brancas, a company that handles, open banking infrastructure for about 4 or 5 countries in Southeast Asia. And a bunch of other companies in between, an identity verification service, and all of that. So what I'll be talking on today is designing predictable complex systems with AI-assisted development. I should apologize, the name is long. So, the title is long, but essentially what I'm going to talk about is how you can harness AI, how you can harness AI tools, how you can harness AI concepts, and how you can add concepts to help you build more interesting applications than CRUD. I know you guys were arguing about CRUD one time on the internet. So, let's get into it. So the first thing is essentially, unless you've been living under a rock for the past few years, AI, there's been a boom in AI. It's been one of the most consequential things to happen in tech. It's one of the most consequential things to happen generally in the whole world. And it's probably had one of the biggest effects, in my opinion, in tech. For example, you have companies that are trying to essentially they're scrambling to figure out AI workflows for their specific teams because, as I always say, AI is very nuanced. You kind of have to create a solution for your team or for your person. You have people setting metrics on AI use. At a company that a friend of mine works in, they essentially track how many tokens you use to get your job done. You have engineering managers, you have what's it called? Sales engineers building super fast, building prototypes to reach out to customers early, to be able to, get feedback from customers early. You have, speed of prototyping. So it's been a whole, it's been a whole thing. Now, while AI has, come in, has changed a lot of things, there's been the good, there's been the bad. Some of the good, speed. If you as a developer are taking advantage of AI properly, you can probably ship out something that 3 or 4 people would do in the space of, what it would take 3 or 4 people to maybe 2 weeks to do. And this is roughly an actual scenario in my head. You could build it out in minutes, in days. There's the accessibility. You're not limited to Stack. You can expand your toolkit, you can expand your stack. It's allowing people that ordinarily only wrote in Node and JavaScript. I have personal beef with that, but it's allowing them learn Go, it's allowing them write in Rust, it's allowing them build infrastructure applications, it's allowing people essentially have access to tools faster than before. Terraform, for example, this particular project I've been working on, I've not been too familiar with Terraform for the past few years, but I'm just familiar with the concept. So essentially, it was all AI's work with a bit of guidance from me. Now you have the exploration, the ability to explore ideas that comes with it. You can bounce ideas off with whatever LLM or AI assistant you use. I don't know, there's ChatGPT, all of them, Gemini, and all of them. You can explore ideas. You can essentially test out scenarios. You can test out configurations. You can test out, architecture faster than before, and before you have to get into the nitty and gritty of it, which, essentially, and all of this all leads to a massive increase in productivity. There has been, there have been statistics going around showing the sheer amount of code being pushed, if that's the metric we're using. The sheer amount of code, the sheer amount of features being pushed. You have companies pushing out features in minutes, you have companies pushing out features in days, you have one person handling features and all of that. So now, the bad is, number one, the most obvious one, hallucinations. And if you're not familiar with hallucinations, it's essentially the tendency for most of these AI applications, these AI chatbots and AI based solutions to answer inaccurately in a bid to answer your question. So that in a bid to answer your question is very important. So you have to be very specific, you have to be very careful about the types of question you ask. Because if it doesn't know, it will answer inaccurately, which could lead to problems down the line. It has increased what I call the dev cycle, the steps you would take ordinarily to commit code, to push code to to production, all of that. It has increased the amount of steps that you'd have to take, and that could lead to more points of failure. Now I'll touch on that in a bit. And yeah, it's again, AI amplifies good code, it amplifies bad code. So if your code has a lot of tech debt, I promise, and this is from personal experience, you will have a lot of tech debt. Like it will get to a point where you start considering rewriting the whole thing if you essentially just build on top of tech debts. And this is an actual scenario, something we are fighting at work. But in that way, that's beside the point. Now, this was 2024. I would say it has improved, but essentially there was a statistic, nearly half or 45% of AI-generated code contains security flaws, or despite appearing production ready. And the despite appearing production ready also touches on something important, I think, that happens with AI-driven development. The thing with AI or AI-driven development is when you ask it for solutions, it tends to write solutions that looks like it should make sense. Like if you just do a rough scan of the code it wrote, it all looks like it should make sense. It looks like this is what, okay. It looks like this is what, should be the solution. But the more you probe into it, the more you see inaccuracies, you see inefficiencies, you see code duplication, you see that's where the hallucination begins to creep in, because hallucination usually doesn't happen at the highest level. It happens at the tiny level. For example, it uses a wrong config, a wrong flag. That's in the wrong place, can bring down your entire application, although you might not know about it. So we'll talk about how you can mitigate with all of that. So essentially, these are the problems that you would face if you are just blindly rushing into the AI craze and doing what I call, or what people call vibe coding, which I have beef with. Yeah, so earlier I mentioned it has caused an increase in the dev cycle. Now, what I mean by that is ordinarily in a company, the path to production, the path for your code to production is they give you the junior or the mid-level engineer, whichever engineer, and they give you the feature, you write the code, your teammate or your lead or your tech lead does the review, and then you merge. But now, you write the code or you prompt AI to write the code, you have to look at what AI has written, and then you move it to review for team review, and then you merge. Now, there's an extra step here. The problem with that is now there's what's it called? Software over time would get less stable and secure. Why? Because you have more points of failure. Depending on who you are on your team, for example, if you prompted AI to write code, you didn't particularly review it properly. And like I said, AI has a tendency to make code look good, make code look like it should work. Your teammates might not put too much attention into what you wrote. You have bad code getting into production, and they're looking for who's going to be fixing bug at 12 a.m. in the middle of the night. But yeah, so that's how over time it begins to get less stable, it begins to get less secure, because you have these minor issues that you don't pay attention to. Because like I said, with AI, you can't just shift. There's a shift in the cognitive focus. You have to focus on something else. You're not more focusing on the intricacies, or the if-else statement. You're not focusing on all of that. You're not focusing on how many parameters does this function have? Is the syntax correct? You are mostly not focusing on that. You need to start focusing on other things, which we'll get to. Now, software grows unmaintainable. With that, yeah, there's something I have noticed over the past 2 years of building this project, is if you start a project with if you start most projects with AI, essentially, and you don't give it a guiding framework, a guiding principle, it tends to have a rough foundation. And with the rough foundation, the more code you add to it, the more maintainable it gets. And essentially, if you're a developer that is not pragmatically taking advantage of this, you're going to regress, because you're not learning as much, you're pushing bad code, your peers are going to outperform you and all of that. So now, we've talked about the pros, the cons, the worries, the things you have to pay attention to. Now, how do we build better with AI? And the solution is simply you have to look at software engineering as a design process, rather, because for the longest time, so when you have conversations about programming in boot camps, in these easier to access institutions, boot camps, tutorials, all of that. They don't particularly touch on the design aspects of software engineering because, as a beginning engineer, you're going to be focused on the more technical things, the language syntax and all of that. So with AI, you don't have to focus on all of that. Now you have to start looking at it as design. And what do I mean by design? To give a brief definition from one of my favorite books, I'll put the quotes later. But essentially, it's the process of having a visual or a rough idea of the system you're trying to build with the limited information you have, because the thing with software is it has to be able to grow, you have to be able to add to it, it has to be able to, you have to be able to make changes. That's the advantage of software over hardware products. So if you don't have all of those, then you're kind of building rubbish and you're costing the company money. Now, the first step is, the first issue, like I said, is the predictability. How do you ensure predictability in a system that is inherently, that still has like inherently still has traces of unpredictability, statistical based system? How do you build a predictable system based off that? For me, I have a mental model I try to approach every time I'm trying to approach a problem. So if I'm trying to, I have a feature I need to build. If I'm trying to approach it, the first thing I think about is, okay, design as much as possible. You don't have to go too into the nitty-gritties, but we'll get to that. Then you have to have control systems for AI, not for your code. What are control systems? These are concepts, or they are essentially rules, concepts, or anything that makes sure AI doesn't deviate from where you want it to go. Because again, it's inherently, it does have a good amount of inaccuracy. So you need to make sure it doesn't go where you don't want it to go. You need to make sure it doesn't write what you don't want it to write. And you need to make sure there are frameworks that can remind you that, look, what you're doing is wrong. Rework that. And the last one is to just think of it as a tool, not as a magic solution. And with every tool, you kind of have to get better using every tool. There are techniques to get better. There are techniques to adopt with every tool. You can't just go blindly into something like Terraform. So if you start looking at it like that, then you can begin to approach it in a more predictable way. Now, what do I mean by the design aspects? So as this slide says, we need to embrace systems design. There's a reason why it's very important in most CSE courses. It's probably the most important part of any engineering process. You kind of have to have a rough idea of what you are going to build. You have to have a rough idea of what it's going to do, and you have to have an idea of how you're going to build it. Whether you write it down, whether you take a picture, and it will also help with knowledge transfer. It helps with co-working and all of that, and it also helps. Usually, those kinds of things were left to the team leads. They were left to the senior engineers. But now, with AI, this is what you should be focusing on, regardless of where you are. So if you're a mid-level engineer, you really want to level up, you need to start looking at code as a whole, as a part of a whole. You need to start figuring out how to design it. Now, design in the context of software engineering, it's essentially you need to have specifications for what you're building, for your application. The thing with design is you can have designs at different levels. You can have specifications at different levels. So say you want to build an application, a complex API gateway, for example, you need to have a good idea of what you're building at the top, how everything is going to work. And then when you're not building out the lower level features, you also need to have a good idea of how those are going to work. So in some cases, you will need a system schematic for that. And it's nothing too fancy, but I'll just go through all of them. So I like to categorize the specifications as three: the functional, the behavioral, and the structural specifications. Now, the functional specifications and diagram, they define the purpose of what you're going to build. They define the people that are going to, the entities that either depend or use what you're building. So say you're building an application or a module, a part of an application. In this case now, this is a, what's it called, use case diagram. Product designers or product managers also tend to use use case diagram because, again, it gives them a broad overview of what they're going to build. Now, in this particular use case diagram, we can see what the online shopping system needs to do. It needs to view items. It needs to allow you view items. It needs to allow you make purchases. It needs to allow you make checkouts, and it needs to log in. And the primary interacting element is the customer. And the elements it relies on, the authentication modules, the identity provider, the credit system, the payment system, the payment service, and the what's it called. So There are a bunch of other, what's it called, functional diagrams. I can't remember most of them, but the most important one and the one that I've come across the most is usually a use case diagram. Yeah, and the benefits in the context of AI is that it helps you know what to safeguard for. So, for example, you know that this application is meant to do all of this. You know that you are going to build systems to make sure that everything that your AI partner comes up with is going to conform to all of this. So yeah, that's on the behavioral diagrams. They kind of get into the dynamics, the internal dynamics of your system. So say you are building, or in the case of the online shopping system, the behavioral diagrams, those are the ones that show how each of the elements interact with each other to get each of the functionality out. Again, you don't have to go too deep into this. It just helps you have a rough idea, because in my opinion, externalizing any plan is the best way to know what you're doing. So an example is a message sequence diagram. This particular one, I think, is gotten from the MCP, Anthropic's MCP page, which is it's instead of them writing the whole documentation, this whole thing, they just put a diagram, a simple diagram that tells these are the internal parts of our MCP architecture, the client, the server. The first thing that's meant to happen is initialize requests, the initialized response, the whole thing, the whole enchilada. So in the message sequence diagram at the top, usually what you would have are the internal components in whatever you want to build. So if it was the online shopping service, you could have the database point, you could have the validation point, you could have the payment processing point, and then you're going to use your functional diagram, which is the use case, as a guide to kind of know exactly each of the functionality you need to build for. So again, you don't have to write everything down and block yourself from working. If you don't need to do it, the more complicated what you are trying to build is, the more you have to do this. And I would recommend also making it a part of your documentation process for people that want to work on this. So if you're a solo developer building something amazing and you want to be able to share, you want to be able to allow other people work on it, you need to have some of these things. Now, the structural diagrams, they capture the relationships, they capture the internal schematics, more or less, or the components that interact. So those would be the things you would find at the top of a message sequence diagram. For example, in this one, you have, I'm not sure what it is, but essentially you have a business module that requires accounting, that requires an ordering module, that requires a shipping module, and then the ordering and shipping require a data management module and ordering, and for all of those. This one is a package diagram. Some other ones you have are component diagrams and all of that. You even have dependency charts. Those help you know what code is calling what. For dependency charts, most of the use I've found from them is if I'm trying to plan like a bunch of modules interacting, the thing I usually hit the most is like a secular dependency where one module depends on another module. That module depends on its back. So now the entire compiler doesn't know how to sort out the entire thing. You would face that if you're working in languages like Go, I think Rust, yeah, and all of those. So these kind of things help you mitigate against that. So now we've talked about the functional diagrams, we've talked about behavior diagrams, we've talked about the structural diagrams. Now, yeah, okay, this is the quote I said I was going to say, which is, you can't keep all the design complexity in your head. Diagrams externalize that burden. And that's a quote from creating solutions for ill-structured problems. It's a book on software design. I would recommend software design and architectural design. If you really want to get into architecture and software and systems design, you should probably take a look at it. It helps you figure out how to break down problems, complex problems. You want to build, I can't think of a solution, but you want to build something, you need to figure out how to break it down into problems that you can now attack. Now, we've talked on that. Now, the next point I mentioned was using AI as a tool. And what do I mean by that? The subtext says AI makes good code great and bad code worse. Recently, I was burnt out on one of the projects I was working on, and the sole cause was because I was using AI to work on something that was built fundamentally bad. So it was frustrating. The more AI I wrote, the more tech debt I had to deal with, and all of that. Probably, I don't think anybody should ever have to deal with that. So, example. So, like I said, using AI as a tool. This is an example of knowing how to use your tools. You have two prompts. They probably do the exact same thing, but one will give you more predictable solutions, and one will give you less solutions. In the first prompt, you can read through it, but essentially this allows too much freedom. It doesn't give, a chain of thought, and a lot of models have chain of thought inherently built, by the way, with thinking modules and all of that. But yeah, it doesn't allow that. It doesn't prime your chatbot or your assistant, so it doesn't essentially know priming helps it think of what's it called, the best practices for that particular entity you're trying to make your AI think as. So for example, if you're priming it as you are a senior Go developer, it knows it's going to, in some cases, it's to actually search for guidelines, it's to search for guidelines for senior development, to search for all of that, and then use that in its thinking modules. I know my code editor, Z editor, kind of does that. It has a separate module. Every time you prime it, it kind of looks for guidelines on the internet. So this was an example of good code versus bad prompts. Now, some of the techniques you can use, like I said, is row prompting, which is what I call priming, by the way. Row prompting is essentially where you tell it, this is what you are, act as this in this context. Then you have priming and context loading. So you need to give it as much context as it needs to kind of solve the problem, but not too much context. That's where you start having context pollution. Because with AI, one of the nastiest thing you run into is when you're telling it, don't do this. And because you told it, don't do this, it finds something entirely different just to avoid doing that. And then you now have a whole series of code that you didn't intend to have in the first place. So the best thing to do is just probably ignore it. Don't mention it. You can use it as you can use the benchmarks for success later on. Now, chain of thoughts is essentially guiding it on how to solve the problem. That helps a lot. Yes, a lot of models have chain of thought inherently built in, but that's at the lowest level. Now, if you're trying to, for example, modify a module to get dependency from this, to use a dependency from another module to kind of, do some functionality, you kind of have to tell your model, your assistant, that look at these packages, look at these folders, use that to make a decision on what fields to import, then use that to make a decision on tests, all of that, so each of those steps. And I also like to do something I call the planning phase. Before any solution, before anything that is complicated, I would sit down, prompt, and then tell it to first give me a plan, and then from there begin to format the plan based on my knowledge of the system, or based on my knowledge of software engineering, which usually helps, by the way, because once you just tell it to implement it, it's implementing exactly what you've told it to do. Well, in most of the cases, most of the times. The self-verification checklist, that is these are the checks and balances you place on your model to kind of know when know when it's going the right direction or when it's going the wrong direction. Most of those come from testing, which we'll touch in a bit. And the test integrity constraint is to also make sure it doesn't modify certain tests to fit the solution. So, again, AI does have a tendency to overcompensate. If it's not getting to the solution because the tests are breaking, in most cases, just change the test, or to change the entire logic, and you wouldn't know because, tests, you wouldn't know because you don't have some form of early warning system. Now, you can read more on a bunch of other techniques that you can use to prompt your models better. Another thing on using what's it called, AI as a tool, is you now have to start using it for autocompletes, like next level autocompletes. You want to write out test cases. You want to write out edge cases. The thing that I find the most useful for is thinking up edge cases. If I'm building something, I've written this first set of tests, I now ask it to think up edge cases that could potentially come up, then write tests for those. Don't change the logic. I'll test it myself and figure out if the edge cases are already catered for. A bunch of that, then integrating AI tools into your workflow, like what's it called, GitHub Copilot. That has saved me so many times, saved my company so many times as well. Because again, things go past review, but the more reviews you have, which is GitHub Copilot or any other AI Copilot tool that checks your PR, all of those is using AI as a tool, not as some omnipotent, omniscient, miracle working program. Now, the test parts are super important. I know there has always been a debate on whether TDD is the best or TDD is not the best. Look, if whoever is telling you that you should not write tests, the person really doesn't like you, because tests are a good way. So for example, how I mentioned you have your use case diagram. For most product managers, how they think about those use case diagrams is what they use. Those are the diagrams they use to do QA tests. Now you're bringing it to the engineering layer. you need to have tests that essentially ensure system functionality. So every time AI writes code and the test integrity checks come in, it sees that, okay, I've done something that's bad, the tests are going to probably kick in. Some examples of tests that would come in handy: the more complicated the application you're building, the less you would probably need this one. But something I find super important is chaos tests. Those types of tests, when you have multi-application system, they kind of simulate breakpoints. So, for example, network failures, corrupted inputs, spamming inputs, trying to overflow your buffers, all of that, those things that you wouldn't expect to normally happen. You should have tests for those scenarios, especially, again, depending on how secure, how reliable what you're trying to build is, how reliable what you're trying to build is. Now, end-to-end tests, again, not all of these tests are compulsory. You just have to have some tests that cover some functionality. End-to-end tests, those ones, they check the entire workflow of a module, an application, a software, whatever it is. They simulate user actions. They do what a typical user would do. If it finds any breakpoint, it would essentially tell you. Some of the tests you probably you're familiar with are playwright tests, large-scale playwright tests that simulate login, tests that simulate registration, all of that. Unit tests, again, maybe not compulsory, but those ones help you, check and make sure the integrity of lower-level functionality you work on make sure the integrity of them, those functionalities are intact. Now, what does all of this mean? Yeah, AI has come, AI is here to stay. AI is not taking everybody's job. You just have to be able to take advantage of it and get better at your job. If not, it's somebody else that's getting better at AI that will take your job, really. And how I like to think of it as, AI is the engine. You don't have to write as much code as you had to before. And I'm not even kidding. I have written PRs that are in thousands because, and in minutes because of AI. Typically, that would take days, but that is written in minutes. It's the planning that takes a lot of time. Design is the steering. You need to make sure that you're telling your system where to go, what to work on with your behavioral diagrams, your functional diagrams, and your structural diagrams. Those help you set benchmarks. Those help you set checks and balances. And testing is essentially the brakes. When AI is going haywire, pump the brakes. So those three, super important right now in the whole age of the AI hype. And yeah, I think that's pretty much it. Something I will say is in the past 10 years that I've been working, 10, 12, give or take, that I've been a developer, there's been different fads, there's been different hype moments. The one thing that is consistent is the fact that the more complicated what you're trying to build is, the more you have to design. Design is 90% of the work. The code, we're not stenographers. You are engineers that are building complicated solutions for problems that's in the best case, you're an engineer building complicated solutions for problems that you're not even sure exist yet. So yeah, and that is all. And thank you for listening. Yeah. Does anybody have any questions? I'm supposed to take some questions for now. I don't know if I have too much time for that. I might have gone overboard on the time, but yeah. Alpha, question.
Yo, what's up? So my name is Wally, backend engineer, and I have two questions for you. So pertaining to system design, I know you suggested one already, but let's say I didn't know anything before, nothing in my head. What's the first book I should read on architecting systems and software design? That's the first question.
If you don't know anything already, it's your first time, you should first Google a bunch of things, because system design book, they do get very theoretical. They touch a lot of theoretical concepts. But the one I would always recommend is the Designing Solutions for Ill-Structured Problems. I can't remember the name of the writer. I'll probably share it or something. That particular book helps you look at how to take a complex problem and break it down into other problems and then build a design out of that.
Okay, sick. And what tools do you use personally for prompting AI? So specifically with making design plans and stuff.
All of them. Sometimes ChatGPT if I need a clean context. Sometimes the tools that are integrated into my IDE. I personally use Zed. So with that, I can easily add context to my prompts. I have, for most of my personal projects, all of them have an AI autopilot, or sorry, co-pilots in the pipeline. The most popular is GitHub Copilot, but you can probably find a bunch of free ones that you can host yourself and run yourself if you are, that into hacking. But yeah.